Oh, 0. Varsity 1, 2. I don't know if that happened after you left, but varsity 1, 2. So I had 2 wins last night. Way to start the season. All right. So looking at this bell work here, this first one is using what we talked about yesterday. Finding our transformations. That means we're going to find our A, our H, and our K. So, are you good? What is our A? 2. What does that mean is going to happen? So A is 2 with you on the value. What does an A of 2 tell us it's going to be? I heard it. It was very quiet, but I heard it. Who said it? Say it louder. Stretch. Hey, that's our big kid. They're gonna do big kid yoga and they're gonna do a big stretch. Hang on, I change this so you don't have to zoom in to see my good handwriting here. So an A of 2 means this is a stretch. What is our H here? 3. Good. We even caught that sign change. Because which way is this gonna go? Right 3. I'm going to do it with an arrow because I'm lazy. There we go. And then what's our K? 1. What does that tell us? Up. Up 1. Okay, I would definitely count that as finding my AH or K and identifying my transformations. Stretch, right 3, up 1. You do not have to write in words. This is math class, not English class. Symbols work as long as the information you convey is clear. You can also do R3, L3. U1, E1. Like, I don't care how we word it. Just make it clear what we're saying. So this second one is taking these piecewise functions and kind of working it backwards. I've not done them this way before. We've given you equations and had you graph them. We've never actually had to write the equations for them. So this is when we would get our equations that say something like f of x equals, and then it has that big squiggly bracket. And since I have 3 little pieces here, we're going to have 3 things that we need to write. So we're just working backwards on these piecewise functions. So how might we describe this piece? If we have a horizontal line right there. What might that one's value be? 2. But only in specific circumstances, right? What are the rules for my x's for that piece for 2? Yeah. So x is going to have to be less than -2, because that's where that is here. -2. All good. You have the exact right vibe, though. And it's less than, not less than or equals to, because of that open circle. My x also has to be bigger than -5, because there's not an arrow on the left. And we usually put the word if in between, but I did not give myself very much space. If, or when, or so. Most any, those conjunctions? Maybe. Little words. Like participles, maybe? I don't know. Again, not an English teacher. I'm not an English teacher for a reason. If, when, so, something like that. Or for. So I'm going to jump over and do this one because it's another straight sideways piece, and that is sometimes a little easier to spot. So what's the value for this one, the purple one on the far right? Yeah. So the value of my line is -1. So -1 over here. And my rule for my x's, what do my x's need to be? Greater than 1. So for, if, when, so, I don't really care what the word in between is. It's just a visual break so that we don't think it's -1x. Hello, hello. All good. Yeah, I got you. All right, well, we're just starting warm-up things. I'm going to hand you one of these. And you can sit any place it's open. Except for that one. He's just not here today. All right, so our last piece here, this one's probably the hardest one to find the pieces of. Piece guy, because it is not a constant. So we're going to need an equation here. Luckily, it's right on the y-axis, so I could have an mx plus b situation. I can find my slope, I can find my y-intercept. What is my y-intercept on the green piece? Where does it cross the y-axis? Zero. So my b is 0. What's my slope going to be on this one? How far from this point? It goes up 1 over 1. So my slope's going to be 1. So if we write this in slope-intercept form, we're going to have our 1x, and if it helps you, put the plus 0. 1x plus 0. That's my mx plus b. You don't have to put the plus 0. It's not doing anything for us. It just is what it is. What is our restriction on our x's? What do my x's need to be? Say it again. Yep. What is, so like we have for this one, my restriction for my x's, this one had to be between -5 and 2. What does this one have to be between? Positive 1 and -2. And are they going to be less thans or less than or equal to's? How do we know that they're equals to's? Because it's closed in circles on the end. Excellent work, guys. We've not done them that direction before. Excellent work. Excellent work. Okay, good job. It's not easy. Especially not to do that the first time at 7:15 in the morning. Okay? That's not easy. Really good work. Okay? All right, so kind of like we were saying at the very, very beginning before we started working, today's going to be the last day of notes for the quiz. Okay? So we're going to talk more using our transformations form stuff from yesterday, like this top one with our A, H, and K. What's up? Okay. So we're going to start with reading transformations from a graph, and then we're going to do 2 more graphs using our A, H, and K. That means I have more graphs for you. Luckily, it's only 2 that we're drawing today. Not bad. 2 drawing today. Pretty easy going on a lot of things. All right, lift it dead. And, oh, I'll grab him from the back then. I don't like Super Dog, but it's cheaper than... All right, anybody else need their places listed? Can we get another pair of scissors? There's only 2 in the box. Scissors in. Oh, my God, this is just a big road of scissors. Oh shoot, now I don't know what it is. That one's down, okay. There you go. Alright, give me the dead scissors, but throw them away, not make them look like they're actually not broken. Oh, no, somebody else. They're real broken. Missing a handle. Throw the dead roosters away. We do not keep them. We do not need souvenirs. There we go. We don't need the pointed ones, but we definitely don't need the ones that have less release. Alright, second pair of scissors. They're not broken. Alright.
At 7:30.
You know you gotta do that.
Alright, so what we're going to do is we're going to look at this picture here. You guys have this one. This is the top one, the U-shaped one. And we're going to figure out what happened to g of x. In my case, it's the orange one, and yours it's the light gray. What happened that made it move from where it started on f of x, our parent function, to where it is now? What happened to this blue one to make it move down here? How did it get moved? What do we think? How did this get moved? Ooh. Think in terms of left, right, up, down. This thing went down 4. 1, 2, 3, 4. So if it goes down 4, what letter is that in our transformation form? If it goes down, K. K is down. Remember, H is the hula. H is horizontal. What else happened? Because that would have just put it straight down. This isn't just straight down. And it went left too. What letter is that? H. So do I have these set right? Does an H of 2 mean left 2 and a K of 4 mean down 4? Or did I forget something? The negative. Left is negative and down is negative. So it's not just the number. We need to pay attention to the direction too. So what we're going to do to write down this transformation is we're going to relate g of x to f of x using our kind of generalized transformation thingy we did yesterday. I'll put the when we had it there. So our y equals, that's when we had our a x minus h plus k. That guy? Ooh, k's purple. That guy? But this time I know what my y is called. My y is called g of x because we're describing the new one. And instead of just putting an x, since we're moving a function, we're going to make that be f of x. Doesn't change anything else. It's just f of x in front. Oh, thanks. So I'm going to show you what it looks like. So our y is our g of x because we're describing the transformations that happened there. When we're reading these off of graphs like this, I'm not going to make you guys try and figure out an A, just because that's mean. Finding an A from a picture is obnoxiously hard. Just saying. So we're not going to have A values when we read the equations off the graphs. Just not a thing we're going to do. So if I don't have any A values, it's a 1. And then since we're moving f of x, I'm going to have this be my f of x. So instead of just putting the parentheses, I'm putting my f of x. But I'm still going to put my minus h inside. So we're going to minus our h. What's our h? Negative 2. So x minus negative 2 becomes plus 2. Double negative. Minus negative 2. The minus minus becomes a plus. And then we're going to add k on the end. So we're going to go plus negative 4. Or minus 4. The awkward part of this is squeezing this f in here because it feels weird. Feels weird. Because it's on the wrong side of my equation. If we know what kind of function this is, we can use our kind of generalized form. Since this is a U-shaped one, we know that that would mean the parentheses is being squared. If it's an absolute value, the v, we could use that. Instead of using the f of x, we could use whatever the function is, but we can also do it this way. Both ways are fine. And that's all we need to do for these. We're just figuring out how they are moved, in what direction, and what would that do to the equation. Okay, so this is our answer on this. Questions on this one? We're going to do another one because I know they're weird. It's not something we do super commonly, but I just wanted us to practice both directions. What's up? K is always going to be how it's moved vertically. That's our kite. It goes up and down. H is horizontal, does the hula. A is when we have our big hit yoga and we stretch. All right, so this one cute, I want to squish it and we compress. And I genuinely do not care if you giggle at that. I will be ridiculous to get you guys to remember stuff. I have 100% no shame about that. None. Say, just wait until we get till like, let's see when we do it. April. I get ridiculous with that one. Just saying. Things to look forward to. All right, let's try this again. Another one. How is this one moved from f of x to g of x? So it went up 2. 1, 2. So up 2. And it went right 1. That's a weird G. Why is that not working? Oh my gosh. Hold for a second. I can fix that G because it looked weird. Now that looks worse. Close to being nice. My screen's arguing with me, but still better than it did on Tuesday. That was a lot. All right. So if it goes right 1, what letter is that? H. And what value does H have here? 1. Positive 1. Right is positive numbers. How about the up 2? What does that tell me? K. And that's going to be what value? 2. Positive 2. Good. So we have 2 different ways we can write this. And I'm going to show you both. And I genuinely do not care which way you do it. Y'all, I have pencils over there. Don't fight over them. Surfing Cat has pencils if you need them. Don't need to fight over your pencil. You also don't need to be sharing a pencil. All right, so we could do this exactly the way we did our quadratic one on the last one, the x squared, where I realized that the g of x is the same thing as when I had my a of 1, and I'm going to take my f of x minus h, x minus h, plus k, plus 2. 100%, same way we did the last one. Totally fine. Or we can go, I know that shape. That is an absolute value. We've worked with those. The absolute value. Value. So I could write this as just the straight up function rule for the function. Instead of putting my f of x, I'm going to put my 1 and then my absolute value bar. X minus 1 plus 2. It genuinely does not matter to me which one you do. It's doing the same thing. It's noticing that it has been moved from its parent function, right one, and up 2. So you can use a generalized form, which is the top one, or our transformation form of our function, the bottom one. I don't care. Either one. It's like we've seen these before. Absolute value transformation form. If you wanted to do the same thing with the u, and that's this guy right here, that's our quadratic, x squared. We haven't seen those since the end of Algebra 1, but we'll get back to them eventually. We'll spend a couple of chapters with them. We work with them lots. Whoop. Okay, so questions on these, we're mostly just looking to see where it has moved from the origin, from that 0, 0. Okay. So I want to go back through and do our graphing and why the heck we care about our a, h, and k, and practice using our parent function transformation to graph again. Because it's honestly way faster than what we did the first day for absolute values. So we're going to graph 2 absolute values today. That's why you have 2 graphs. Shock! So we've got our f of x equals 3 times the absolute value of x minus 1 minus 2. And this is what we're going to graph. I need to get the coffee.
Just when I walk outside first thing in my house, it was clear. But when I get to like,
Oh, it's been hitting hard this year. The allergies are allergying. Allergies are allergying this year. Like it is not just you. They are. The trees are bashing people in the head with this pollen season. It's crazy. The cottonwood's about to bloom too, and that's gonna be nuts. All right. So the way we're going to do this is just like how we did yesterday, where we're going to find our a, h, and k. So what is my a here? 3. What is my h here? That is the wrong color. What's my h here? Ooh, careful, careful. Careful, careful on the h. Positive 1. H is the opposite. Always has the opposite sign of that expression. Every single time. Always, always, always. X minus h. All right, what's our k? Negative 2. Good. So when we are doing these transformations, we're going to start by putting our parent function in the middle. That is our basicest of basic-y basics. That's when I'm going to do my no h, no k, no a, y equals the absolute value of x. Basic-y, basic, basic. That's called my parent function. Where we pick our x's to find our y's. And we use our new best friends that we are going to see a bunch of times in almost every graph we do. What are our new best friends for our x's? Negative 2, negative 1, 0, 1, and 2. That good view of the middle, our new best friends. We will use them in almost every graph we do for all of the year. The whole year. The whole year. So using those 5 values, our absolute value, our y values are going to be what? What is the absolute value of negative 2? 2. What's the absolute value of negative 1? 1. Absolute value 0. Absolute value 1. Absolute value 2. 2. That calculation's easy peasy to do. No problems there. The problems we were having on, like, what was it, Wednesday, was that it was just taking so long to plug and chug everything into that equation. So that's why we have our transformations here, is because now I can take my table and expand it outwards. And again, I build it like this. You do not have to. If you want to do 2 separate tables, that's fine. If you want to work outside in, that's fine. We are literally going to use this in every chapter. So at some point you're going to find a way that works best for you, and that's okay with me. So we're going to do our transformations. That's where we're going to take our x plus h on this side. So I'm going to take my x's for my parent function and add 1 over here. So what is negative 2 plus 1? Negative 1. What is negative 1 plus 1? 0 plus 1. 1 plus 1. And 2 plus 1. I ask you such hard questions. All right, so our x's, it's x plus h every single time, and that is true, again, for everybody. For our y's, we can always remember how graphing makes us yak. Ya plus k. Y times a plus k. Graphing makes us yak. We good? All right, so we're going to take our y's from our table times 3 plus negative 2, or minus 2. So yeah, this is more calculation than we did on the x's, but it's still less than we did on, what was that, Tuesday? Yeah, Tuesday. When we had like the tables and we just plugged and chugged and it took us for freaking ever to do one. So what is 2 times 3 minus 2? 4. Way easier than the absolute value stuff we did the other day. So now we're going to do 1 times 3 minus 2. 0 times 3 minus 2. Negative 2. Good. 1 times 3. 3 minus 2. 1. 2 times 3 minus 2. 4. So the calculations doing it this way are significantly easier, to the point we can almost do them in our head. You could absolutely use the calculators, totally fine. But this is easier to type in because calculators don't have an absolute value button. This we can do. Okay? So now when we're trying to graph it, I'm going to cover up the middle piece. X's, y's. X over here, y over there. So the point negative 1, 4 is one of my points. So we've got negative 1, 4. Again, covering up my middle, my next point is 0, 1. 0, 1. 1, negative 2. 2, 1. And 3, 4. I want to thank our lovely janitor and all of our others again. Oliver here. He is so helpful for us. It's a little over helpful sometimes. I would much rather clean my rulers too hard and not clean them enough, but. All right, so connect them up using a ruler. Start with mine. Because people get silly with my ruler sometimes. All right, so absolute value, that's our V. And we can look at our graph here and make sure it matches up with what we expected it to do. Does this match the transformations that we looked at before? So an A of 3 tells us it's going to do what? Stretch. This went big kid yoga, tall and skinny. That's exactly what that did. That is definitely taller than it was before. What does an H of 1 tell us? Right 1. It went right 1. How about my K of negative 2? Down 2. This seems to match up just fine. We will also see for observant. My h wound up here, and my k wound up here. That will be true as long as we set everything up properly, that this is my h, and that's my k. Every time. You got a question, guys? All right, we're going to do one more. These don't take super long once we're in the vibe. Okay. One more. So now we have our f of x is negative 1/2 times the absolute value of x plus 1 plus 3. So write the equation down. Then we need to find our a, h, and k. What is my a? Negative 1/2. What is that going to do? It's going to compress. It's so little and cute, I want to squish it. It's going to compress. And it's going to reflect this across our x-axis. Yeah, it's going to go upside down. So this one's going to be very different looking. What's our h here? Negative 1. Good. Which direction is that? Left. How about our k? 3. Which way is that? Up. Okay, our parent function is exactly the same. I'm still going to put that same dude in the center. Still sticking with my y equals the absolute value of x. That's my parent function. We pick our new best friends for our x's, and we find our y's. Negative 2, negative 1, 0, 1, and 2. My y's are the exact same ones we had in the last graph in the middle. My 2, 1, 0, 1, and 2. Exact same. It's the absolute value of my x's. So then I'm going to expand my table out further so I can do my transformations. I'm going to do my x plus h over here. So I'm going to take my x's and add negative 1 or subtract 1. What's up?
Why are you starting at
Because we want that good view of the center. So 0, 0's in the middle. And I need some that are smaller and some that are bigger. But we need 0, and we want a good view of the center of our graph. That's why it starts at negative 2. All right, so when I take all of my x's from my parent function and subtract 1, what do we get? Negative 2 minus 1. Negative 3, and then negative 2, and then negative 1, and then 0, and then 1. Doable. Totally fine. Our y's are going to be a little bit grosser, but that's okay. We can do this. Remember, graphing makes us yak. Ya plus k. So we're going to take our y's times our a. So we're going to go times negative 1/2 plus k plus 3. And you may want to use a calculator for this. You don't have to. We can do it in our heads. So if we have 2 times negative 1/2, what is 2 times negative 1/2? Negative 1. Plus 3. 2. You can also type it in the calculator. 1 times negative 1/2 plus 3. What we got? It's not going to be 1.5. You're close. Because 1 times our negative 1/2 is just negative 1/2 plus 3. Or 3 minus 1/2. 2.5. We should get a 2.5. or 2.5. I do not care if you write decimals or fractions. On the next one, 0 times negative 1/2. We love 0. 0 is so easy to multiply because that's 0 plus 3, which is going to be 3. 1 times negative 1/2 plus 3, 2.5. And the last one's going to be a 2 again. And we have our x's, we have our y's. We can plot this, and then we're done. -3, +2. -2, 2.5. -1, 3. 0, 2.5. And 1, 2. So we can see our V shape. We can grab our ruler. And then we can see that this matches. This is upside down, so it's been reflected across that x-axis. It kind of looks like somebody sat on it. That's compressed. It's been squished because it's just so small and cute. It has gone left 1. It has gone up 3. So it matches the transformations we said at the beginning. So a way to kind of give yourself a quick spot check is to think through your transformations and make sure your graph matches what you think it should do. Does it do what you expected it to? Okay? Questions on this one? Or on any of them? That's it. That is the end of Module 1. Okay? So homework 1-7, you guys can now do everything on it. So the front side is just naming our transformation. The back side, these 3 are like the first 2 where we're identifying how it got moved from our 0, 0. And then we've got 2 absolute value graphs. I also have up here that you're welcome to pick up, otherwise we'll give it to you tomorrow, the chapter review. Because we've got a quiz on Tuesday. So I have the review for you. Otherwise you can have it tomorrow. Like, that's fine with me too. But we have like a minute until the announcement reminder goes off. But look at us being done on time. We love that. We love that. All right.